Okay, good morning. Not see many people in the chat, so it's possible I'm just speaking to a later video audience, but if you are here watching, good morning. Hopefully things are okay for everybody there. I know that there's been sort of a continuing, at least, threat of disruption, power outages, evacuations, so I hope that that hasn't affected anybody, but if it has, hopefully you're finding ways to settle down around all of that, and I'm glad that you can take some time to watch me now or watch me later talk about Linux stuff. So we're in week 6. We're making really great progress through the semester. It's my way of sort of counting down the progress through the semester is just think we've gotten ourselves through another week. So that feels pretty good. Alright, so I'm going to start where I normally start, which is, in fact, I probably should just say, I always start here, and then eventually I'll stop saying that. Just to look at the homepage and get a sense of what's coming up, what we're doing right now, and remind you about the things that are out there in your not too distant future. So we're in week 6. So this is the third of 4 weeks where I'm sort of just trying to get you to a minimal comfort level with VI. The reason why VI is because it is more reliably universal than most other text editors. And what I mean by that is if you install a BSD, if you work on a commercial Unix system, if you work on a Linux distribution, the odds that you're going to find VI are almost 100% in my experience. And the other editors may or may not be present always. So Nano is a very popular editor, in part because it's a lot easier to learn, and it works fine. But it's not as widely sort of automatically installed as VI is. And the same goes for Emacs in my experience. It's not always installed, especially when you do a minimal installation on a system. And in my experience, VI is the most likely of those to just be pre-installed on the system. So I think it's useful to know it, at least so you can open up a file, do some basic editing, and save the file. So that's why VI. I will tell you that for a long time I was an Emacs user. That was my first Linux editor, and I still use it a little bit for working in certain programming languages. Emacs has got some nice functionality to it. But honestly, my main is VI, so I do have a bias toward the VI editor. Okay, and then we're also going to do some more sort of text manipulations on the command line, and the star of the show is doing redirections and pipes this week, week 6. Okay, so this week ends on October 4th, and I'm saying that just so that you start planning some time in your schedule to deal with the midterm exam. So the midterm will open up so that you can begin to work on it on October 19th, and it will close itself off on October 25th. That's a Sunday at midnight. So you have a full week to work on the midterm. The things that are different about it, it has 50 questions as opposed to the typical 20 questions, so there's more questions. All of the questions are drawn from the first 8 weeks of the semester, so I'm using Canvas's functionality to pull questions from the prior weeks kind of randomly to build the midterm exam, so it's the same questions. And you only get one shot at it. There's no timer on it, so if you start it on Monday and don't submit it, then you can come back to it for as long as you want or need to through the week. But once you click submit on the midterm, that's your one shot at it. So please leave yourself time to work through it carefully when it comes to the midterm week. Oh, War Dog's here. Morning, War Dog. And whoever else is watching. So that's coming up. The team projects, the first one is due on November 8th. It's not a hard one. For most of you, you might even be able to work through it in one kind of long sitting, a few hours maybe. But you need to start communicating with each other. So what I strongly encourage you to do is to find the groups link in Canvas, click on it, find your group for Team Project 1, and initiate some communication. So do an announcement, send a Canvas message to all your team members. Somebody, one or more people in your group need to take some initiative and start getting people communicating a little bit, because you don't want to wait to the last second and then people haven't kind of planned to make their contribution for the team project. So if you, and no one has in this class, so please consider being that person who initiates the first contact with the rest of your team members by finding the team link, clicking on it, and then using Canvas to either make an announcement for your team or to send a Canvas message to the rest of the members of your team. Okay, so that's what's going on sort of beyond the immediate week. Week 6. So I'll step through, as I always do, the contents of the module just to orient us, and then we'll do some of the experiments. So we're going to use redirection. Some of you, I know some of you already have this experience, so nothing new for you, but obviously the assumption is that we're teaching to people who have never touched a Linux before. So redirection is something that I use a lot of, and I expect that you, if you ask anybody who works in a Linux environment, they use the redirection operators quite a bit, especially system administrators, for scripting and for sort of combining, getting the most power out of the command line tools. We'll add a few more commands to experiment with. Sort, unique, and cut are the big ones. Also we'll do translate, which is kind of cool. And then, as always, I'll kind of stop and read through the man pages just to share with you my process, which is someone tells me about a command, I open up the man page, I read about what it does, I see what it does by default, I look at what the options are and sort of try those out to see how the command works. And then for VI, hopefully you'll find that I'm offering you at least some opportunities in the hands-on experiments to create some files, and that's an excuse to use VI at that time, just to do some simple editing. And then we'll add a few new techniques into our VI toolkit. Okay, so I know this looks like a lot of readings, and it won't stay this way forever. It'll get shorter and shorter and shorter. But most of these chapters are only a few pages at a time. They're not just a whole lot of stuff. So hopefully you're not finding yourself overwhelmed by the readings. But they will get sort of fewer over time as we sort of build up our toolkit of basic capabilities, and then we focus in on some slightly more difficult things. I'll come back to the lab assignment. I am going to pop open the hands-on experiments. So the design of the hands-on experiments, and it says it here in the lab instructions, what I imagine that people might do is look at my hands-on experiments first. Either do the reading, then the hands-on experiments, or the hands-on experiments and then the readings. But the hands-on experiments, as I've been saying, are what I create as I am creating your lab. So I'm writing questions in your lab, and I am experimenting with the commands myself. And when I find that it would be useful to create a file with some content in it, then I do that, and I share that. I show you what that file looks like in the hands-on experiments. So that's meant to assist you in working through the lab. So I opened that up in a separate tab, and I'll come back to that in a second. So some of you have begun to already sort of do the Piazza discussion, and I know this can be a little bit tiresome. I'll just try to sort of beg your, what's the word I would use? I would ask for your patience about the discussions, because the effort is to keep us all aware that there's a whole bunch of us involved together in learning this stuff, and because we're online, it's one of the easier ways that I can think of to allow people to work on the class whenever it's convenient for them, but at the same time go somewhere and kind of show the rest of the class that, hey, I'm here, I'm talking about the same stuff that all you guys are. So that's the idea of the Piazza discussions, is to try to recapture a little bit of the interactions that we would have had if we were in a live classroom. And some of you have already posted to this discussion, and I can see that you're able to draw on your experience, which is awesome. But if you're new to Unix, then Linux, you may or may not have realized that there's Linux out there in a lot of places in the world. That's kind of what the little mini research is about. And then the reminders page. So as always, to remind you what the weekly assignments are, and then to draw your attention to the midterm, which is coming up. The week of the midterm, that is the only activity that you have in this class. So there's no lab, there's no discussion. I will do a live broadcast that week and do a little bit of review. But the midterm, the only thing you do the week of the midterm is the midterm. And then the team projects, which again, I encourage you and sort of ask that you consider being that person in your group who initiates the first contacting and gets you all communicating with each other, so that you can knock that team project out. Okay, so actually I don't need the lab, I'll just I'll open up the hands-on experiments. And I'll just show you oh no, a fair number of people have joined me. So hello everybody who's joined me since I said hello. Tim, First Killer, Dynamite, War Dog, hello. Anyway, one of your classmates has worked ahead and is providing me with a lot of assistance in finding small and large mistakes that I make. So if you find a mistake or you think you found a mistake, please let me know. Even if it turns out to not be a mistake, well, no harm's been done. But I'm generating a lot of content, and the chances that I'm going to make mistakes here and there are quite high. And Canvas makes it quite difficult to kind of go back and review my work, particularly when it comes to those labs. It's very, very difficult, time-consuming, and hard to keep track of what you're looking at. It's very, very difficult to debug the lab assignment. So if you find a bug in a lab assignment, I very much appreciate it if you let me know. I take no offense to it. If I can make these materials be perfect, that would be my goal. Okay, but anyway, I've created and shown you the files that I created that I thought would help me with my experiments. I created a week 6A file, a week 6B file. And then a little shopping list file for using in combination with some of these commands. So the creation of these files, if you're not comfortable with VI, then making yourself create these files is one way to practice the basics of editing in VI and get past the point where you just feel stuck and frustrated, right? It's not that hard to generate a simple text file in VI, and that's most of what we have to do with it. So if you take these opportunities in the hands-on experiments to just do some basic editing, that can be helpful. So when I was doing my experiments, when I wrote your lab, I created these files, which I found useful in running my experiments. Okay, so let me switch views. I've already made a file here that, it's kind of weird, but that's okay, it all shows. I've already made a file that has kind of the things that I want to go over, drawn from your lab and from the readings, sort of the major stars. So the top section is the sort of just the basic text type stuff, manipulating text on the command line, and then the second section is all stuff to try inside of VI. And I left a couple of notes in here, just as a guidepost for people who might be watching the video later. So let me switch up my view and get my virtual box to show. Okay. Pretty soon we're going to add graphics to our CentOS systems. So some of you who have worked ahead, you've already seen that there's a discussion where I ask you to sort of vote on what kind of initial graphics system we will install. So when we get to the week after that poll, then part of my lecture will be going through the installation and the basic configuration of a graphical system. But until then, we're going to just be working in text. Okay, so this is the part of this experience that I like, because I just think it's kind of fun to play around with and show people how some of the things that you can do on the command line. Okay, so the first things to do are redirection. Actually, let me go into let me see if I did a week 6 folder. I did. Let me remove that tilde file. Okay. Pardon me. Sorry, my voice is rough today. I don't know what I can do about it, but there's been a slight change in the weather, and I think it's sort of gunking me up. Okay, so the first thing to do is to talk about redirection operators. And basically the redirection operators, hold on, I'm going to mute and clear my throat. Okay, yeah, that's better. Okay, so the redirection operators, the point is to make it so that we can take the output of a command and send it somewhere other than on the display. So for example, if I do ls, by default the output of the listing is going to go onto the screen. But I can, if I want to, redirect it into a file. So what I'm doing here with the greater than is I'm saying take the output of ls, and instead of printing it to the screen, redirect that output into a file called files.txt. Now the single greater than redirection is an overwrite redirection. So what that means is this single greater than here, if files.txt does not exist, it will be created and then filled with that output. If it already exists, it will be overwritten with new output. So I'm going to create it. I did a listing here already, so you can see there's 3 files. And now I'm going to do a listing, but instead of having it print to the screen, I'm going to redirect the output to overwrite this files.txt with it. So now if I do a listing, there's the new file, and if I use cat to dump its contents to the screen, there's the output of the ls command. So that is the contents of files.txt. Actually, let me use vi to prove it. So there's the contents. So notice the file itself, files.txt, actually is in there also. But there it is. That's the redirected output of ls. So there they are. So what I'm going to do now, and it's going to look kind of weird, but just to show you that if I run the date command, by default it prints to the screen, but if I use redirect, so what's going to happen here is the date is going to overwrite the content of files.txt. Since it's a pre-existing file, the contents of that file will be overwritten with the output of that new command. So the single greater than is overwrite. The double greater than is append. So let me, so I'm going to remove files.txt and start over. So just like the overwrite redirection, the single greater than, the double greater than, the append redirection, if the file is not there, it will be created. So let me do ls. So note the file's not there. So if the file's not there, it's going to be created. So it looks the same as the overwrite redirect because it's the output of the same command, and it created the file anew. Now, if I do date and the append to files.txt, since the file already exists, so if I use the append redirect, since the file already exists, the output of the date command will be appended to the bottom of files.txt. So notice it still has its same contents, but now the date command output has been appended to the bottom of the file. So that's those two, the overwrite redirect and the append redirect. We use these a lot, at least I do use them a lot in scripting to capture the output of commands like to create error logs and that kind of stuff. But the thing to get straight about the two is that one of them overwrites, that's the single greater than, the other one appends, which is the double greater than. So you have to be careful about overwrite because you have to know that whatever, if there's already content there, it's about to be destroyed and overwritten. Okay, so the next one is pipe. So the pipe command, which is the vertical bar on your keyboard, which is right above the enter key. So I sort of think of it as being right above my pinky. That's the vertical bar. And in Linux, and maybe I didn't write that on Notepad, did I? That's pipe. I saw an extra space down here. Hold on, I can't live with that. Okay. This is pipe. So what pipe does is it redirects the output of one command, but what it does is it redirects the output of one command and makes it the input of another command. So one easy way to practice with this is to do a listing, but take the output of the listing and pipe it to something like WC. So if I pipe the output of ls pipe WC-L, what I end up with is a line count of the listing, which is another way of saying how many files and directories are there in this folder. So there's 4 of them. So ls spits out the 4 entries in my directory, and then WC-L counts those 4 lines and says, oh, there's 4 files or directories in PWD, in the present working directory. So that's pipe, and we'll use it in other ways, and you'll see that here in a little while when we add another command. So let me do another simple one, and we'll do the translate command. So let's look at, let's look at translate, and I'll show you using translate with pipe. So translate is TR, and I'll show you sort of a way I commonly use it. So it's a way to translate or delete characters, and I'll show you a really simple application of it. So basically, the sets that you provide to TR are translating from what to what. So let me give you an example. And then we're going to use TR with pipe. That's the reason why we have translate here, is because it's something that you can easily practice with pipe. So if I were to echo hello, of course that just prints the word hello to the screen, but I can pipe it to the translate command, and then I can ask the translate command to translate what is being echoed in different ways. So let's say, for example, I want to translate all of the lowercase letters from A to Z to all uppercase letters from A to Z. which gives me hello in all uppercase. So that's the translate command, but the reason why I'm introducing it here is because I often find myself using the translate command in combination with the pipe and other commands. If you're a Windows user and you've used the command line, then you will know that Windows traditionally is not case sensitive. It is case insensitive on the command line. So in DOS, for example, all uppercase hello is the same as all lowercase hello in the old Windows DOS system. But in Linux, the upper and lowercase letters matter. So one of the reasons why we find ourselves using translate a lot is because in Linux, comparing all small letter hello with all big letter hello doesn't find a match. So we often translate things because we're more interested that the kind of the word matches and not precisely the upper and lowercase letters. You can use translate more simply, by the way. You can just say translate all the little h's to big H's. Or the little h's and the little o's to big H's and big O's. So this is kind of a one-to-one thing, and I'll show you an example of that. So little h's become big H's in the second set, and little o's in the first set become big O's in the second set. But you can also say like, let's not do that, let's just use like a plus, because I think you can see that easier. So here I'm saying little h's in the first set become big H's from the second set, and little o's from the first set become the plus symbol in the second set. So that's not super useful, but translate is a very, very powerful command, and it just happens that it works well with piping. So when we get to pipes, it's a good time to talk about translate, since that's a common way to do it. To use translate by having the output of something be piped. So I can, for example, I can take ls and pipe it to translate and turn everything into uppercase letters, if that were useful. But it is a powerful command, and it does make doing matching easier. If you have a file, maybe I'll make one and I'll show you what I mean. If you have two files that have basically the same words, but one of them is sort of mixed upper and lowercase and the other is all lowercase, if you want to match those things up, translate can be super helpful with that. Okay, but anyway, that's a pipe, and you're going to see more pipe here in just a second. And translate, again, it's a useful command. It's useful that you know it exists, but also that you understand the reason why I'm introducing it now is because using it with piping is sort of a common way that I find myself using it. Okay, what else is on our roster of things? Okay, so now the fun stuff, sort, unique, and cut. So let's look at sort. So we went over overwrite redirect, append redirect, and piping redirect. The difference with the pipe is that it takes the output of one command and sends it as an input to another command, whereas the two greater than, the overwrite and the append redirect, are often used to redirect things into files. Okay, so now sort. I'm going to make a new file real quick. If I struggle with coming up with the words, but let's. I'll call it. I use fruit names a lot because I feel like that's a fairly neutral thing to use, and I can usually come up with a few. So I'm going to make a new file with some fruits in it. When you first open a file in VI, you are in command mode, don't forget. So if I'm going to start typing I to insert. So I'm just going to put some stuff in here, some fruit names, banana, apple, grape, cherry, kiwi. The thing I'm being careful of here, or trying to do, is mix them up. So I have 1, 2, 3, 4, 5 of them. That's enough to start with a very small experiment. Okay, so banana, apple, grape, cherry, and kiwi is what I picked, and I scrambled them up alphabetically so that sort can do its thing on it. Okay, so here's my current files. That files.txt is just that garbage from my redirects. I just made a fruits, that's the one I'm about to play with. So let's just try sort on fruits and see what happens. Actually, first let's use cat on it, just to show it in its current state. And then I'm going to sort on it. So notice that sort's basic job is to alphabetize things. This could be very useful if you have like a text file with usernames in it, or software in it, or something, some kind of text that's kind of a little sort of database in a text file that you want to have ordered. And it'll order it. The fancy word is lexicographically, but most of us would call that alphabetically. So let's keep that in mind. Let's see. Oh, we want to do the man page. So the man page on sort. Sort lines of text files. So you can provide it with options, and then you provide it with one or more files. So let's look at what the options are and then play with them. Okay, there's an ignore case one, so I'm going to keep that one in mind and go edit the file and try that one out. I also want to look at, so dictionary order, I'm not going to worry about that, but you should try it. Reverse, let's try reverse, that seems easy. So another thing that's kind of cool though is see that big -R here? So you can actually take something and shuffle it with sort if you wanted to. So if you're making a game, I guess, in the shell, you might be able to use this shuffling. Or if you had a list of people and you wanted to ask them questions in some random order, you could take your file with all your people in it and do a random sort, a shuffle on them, and then ask each of them a question in random order. Okay, so we're going to try reverse. And we're going to try ignore case after I edit the file just a little bit. So if I do sort -R fruits, makes sense, right? Reverse alphabetical order, so deeper in the alphabet, down toward the front of the alphabet. So I'm going to go edit the file now, the fruits file. And I'm going to add another entry for apple here. So I'm gonna actually add this to the notes because I'm about to do it in VI. So if you're in VI and you want to open up a new line below the current line for typing, I'll add this to Notepad, but that's a little o. Which I remember is open the line below. So I'm in command mode, I'm going to type a little o, and notice it has opened up a new line and put me in insert mode. So a little o opens a new line below your present location and puts you immediately into insert mode so you can just start typing. But what I want to do is put all uppercase apple. I'm going to hit escape to leave that, and maybe I'll try one more experiment. So I'm going to use a little o after cherry, and I'm going to do a capital one just to see what happens with sort. So I was back in command mode, :WQ, because I want to write and quit. And now I'm going to sort the fruits file again just to see what it does with it. So one thing to notice here is that it puts the uppercase letters after the lowercase letters, which could be important in theory. And let's try it in reverse, which we know what to expect, but in reverse then the uppercase letters come first. So that's something to note about the way sort works, where upper and lowercase letters come, but they are different in Linux. It's case sensitive, so an uppercase A is different than a lowercase a. All right, that's sort. Okay, so now what I'm going to do, and I don't know if Zach is here, but if Zach, if you're here, thanks for finding this mistake, and you're about to see what I did, and then just forgot the second step, or I don't know what happened. So here's what I did, Zach, when I made the mistake that you saw on week 6B. So that's what sorting does. It just sorts, in this case, in alphabetical order. We're going to use a fancier sort here in just a second. But I want to show you another command, unique, in combination with sort. So what I'm going to do is I'm going to copy my fruits, and I'll call it new fruits. So I'm going to make a copy of new fruits, and here, Zach, is what I forgot to do when I uploaded the screenshot. Is I immediately went and took a screenshot, but what I should have done is I edited the new one first. So now I have a copy, but I want to actually use VI to open up the new fruits file and make a couple of changes. So I'm going to get rid of this extra apple here, and to do that, I'm going to delete a line. And do my notes say that? They don't. So in command mode, in VI, I'm about to type dd, which deletes one line. I'm going to, I think I will delete both of the cherries, so dd, and then I'm going to add something, maybe a couple of things that are different. So now little o to open the line below. To type some stuff, I like short fruit names, so I already used grape, banana, apple, grape, kiwi. I already used cherry. Well, strawberries, not short, but that's okay. And orange. Let's use those two. So now I have fruits, which we've been playing with, and now new fruits, which I started by making a copy of fruits and then made a couple of small changes. And that's because this experiment is way more interesting if we have two similar files but not precisely the same kind of files. Okay, so command mode :WQ. So if I do a listing now, you'll see fruits and new fruits. So we're going to add the unique command. So let's go use the man page and see what unique does. So report or omit repeated lines. So the way we often use unique is to basically as a means of comparing two files to see, to find duplicates, or to at least find sort of all of the unique entries in that file. So for example, I have classes where I have students in multiple sections of my classes, and if I wanted to get a listing of just all of my students without getting duplicates, I could combine all of my rosters and then use the unique utility to remove all the duplicate lines. That's what unique kind of does. So it will take basically one or more files and remove all the duplicates. That's its default behavior. So filter adjacent matching lines from input. So when two lines of its input are matched, are the same, it will filter the duplicate out, which means at the end that you're left with only the truly unique stuff. Okay, so that's that. And we'll look at a couple of the options. There's the counting option, prefix lines by the number of occurrences, so we'll play around with that. Print all the duplicate lines, -D. Print only the duplicated lines. So if I wanted to see which of my students are actually in more than one section, I would use the repeated, the -D option. There's a case insensitive, a -I that we can use on unique. The -U is only print unique lines, which would, well, we'll play with it, but only the lines that are not, in fact, duplicated. So that's unique. Now, the thing to note, though, and what's important about this is it says it filters adjacent matching lines. So what that really means is you have to sort the input to unique for it to work. So unique almost always has to be used in combination with the sorting utility, or it doesn't actually work. So let's try it out. Yeah. Yeah, well, let's just try it on fruits and see what happens. Unique. Let's just try it without any options on fruits and see what happens. So nothing happens because it's all literally, every line is different. So unique's job would have been to filter out matching lines that are next to each other, but the problem is that there's no matching lines here, so nothing's filtered. Now if I use the -I option, what it should do now is find pairs of lines but be case insensitive. So notice the all caps apple went away and the capitalized cherry went away because now it was looking for duplicates but being case insensitive. So that's useful to know. Now the other thing is, let's see what happens if we do unique on both of those files at once. Let's just combine them all together and run them through together, and there's no output at all. So this is an example of where I would need to use sort to get this to work. So I'm going to sort and then pipe to unique. So what I've done is I've sorted the contents of fruits and new fruits all together, and then piped it to unique to pull out only the unique entries, filter away all of the duplicates. So you notice again that apple and cherry are still here. So let's put the -I option on it. So what this is all of the unduplicated entries between the two files. At least I think it is. Although it feels like something's been left behind. And this is where yeah, so do you see, Zach, if you see this, what did I do? I don't know. My changes aren't there. I gotta go back and change new fruits again. Maybe I forgot to save. So anyway, kind of strange. I think I put, no, I don't remember, maybe strawberry in there. I'm also gonna, I think I'll delete apple. I'll delete banana, no, I'll delete apple. And then I'll use a little O to open up a new line. I gotta put a new fruit, oh, orange. I put orange in there. So I don't know what just happened. WQ. Alright, that's what I expected. So let me just go back and cap those two out. So there's fruits. So banana, apple, all caps, apple, grape, cherry, capitalized cherry, kiwi. And then the new one is now banana, orange, grape, kiwi, and strawberry. So the new one has a couple of different entries in there, and the reason I did that is because I want to use this sorting command and find all of the unduplicated entries between the two files. So those are all of the unduplicated entries. So I did the case insensitive, so the all caps apple got filtered off. So this combines them all. You have to sort them or this doesn't really work. And then it filters off all the duplicates so that what you're left with is a list of all of the sort of unique entries in the two files. Let's try some other options from unique real quick before we move on. So we'll do a count and see what that looks like. We'll do a we'll try the -D option, only print duplicate lines, and maybe the -U. So -C, -D, and -U, and let's just see what that looks like. Okay, so here's the original one with all the unique entries. So let's just change some things and see what happens. So what that's telling us is that it saw that string apple once and the all caps apple once, but the string banana twice. And then you can see grape twice, kiwi twice. So hopefully you get that. And let's see what happens if we combine that with the dash I. Yeah, so case insensitively, it saw 2 apples in there, 2 banana, 2 cherry, and so on. Just kind of cool. I really like that option. Let's try it with, I'm going to leave the dash I in there. Let's try it with the dash D. Which I can't remember what the dash D did. Only print duplicate lines, 1 for each group. Okay. So now it's not showing any anything that appears only once gets left off in this case. So the dash little d means only show me words that actually are repeated between the inputs. Now if I do the dash u, what it should show me is only those words that are never repeated, only appear once, which are orange and strawberry. That's expected because that's why I made that new fruits file. So orange and strawberry are the only truly unique words when you take the combination of those 2 files. I really like these tools. I think they can be very, very useful for scripting. Okay, so there's those things. I've got to watch the clock a little bit. Okay, still doing okay on time. And again, the thing to do is to just give yourself some files, and kind of like I did, except for do it the right way, which is to create a file and then make a copy of it, and then make some subtle changes to the other file. Don't make them super, super long. Make them enough that you can kind of keep straight in your head what's in the 2 files, but then you can use sorting and the unique tool on those files to get a feel for how they work. Okay, so the last one is cut, but we're going to use it in combination as well with pipes with other commands. So let me show you the file we're going to play with, which is this shopping list. So the way this shopping list, this is like a little database again, but it's kind of a shopping list. So each line represents an item, like apples, followed by a space, followed by the category of the item, followed by a space, followed by the quantity that I want. So you can kind of imagine that maybe I'm going to ask someone to go shopping for me, and when you're in the fruit section, please get me 2 apples. When you're in the dairy section, get me a dozen eggs, that kind of thing. That's what this file means, but it's really there to play with in combination with sort and cut. So we'll do cut first, just so you can see how that works. And then we'll pipe it into sort and play around with that. Okay, so here we go. So here's the shopping list. I'll just dump it with cat so we can see it. And I'm going to cut. So the cut command, usually you need to be in the habit of telling it what separates your fields in your file. So my fields are an item name separated by a space from a category separated by a space from a quantity. So my delimiter is the space character. And you put the delimiter in between single quotes. You can put dash D space, or you can bump those things together. I usually put them spaced apart, but I think your reading smushes them together. But anyway, what I'm saying is cut using space as a delimiter. And then what you say is, then you cut fields. So delimiting by a space, which fields do I want? So my lines have 3 fields. Field number 1 is the name. Field number 2 is the category. Field number 3 is the quantity. So when you're doing a cut, you say, okay, how are my fields separated? By spaces in this case. And what fields do I want? Let's say the item and the quantity. And then this is in the shopping list. So what I've done now is I've cut out the name of the, pardon me, I'm trying to nurse my voice a little bit. I've cut out the item name, field 1, and I've cut out the quantity, field 3. And you can play with this, but I can, if I want to, cut out the category and the quantity, or I can cut out just the item's name and the category. So hopefully you kind of get the idea there. So cut's super, super powerful. And let me just give you one more example of cut before we use it in combination with sort. So there is a file in the etc. folder. It's the password file. We've looked at it before. If you're a sysadmin, then you're going to know of this file. But anyway, it's a super useful file for doing experiments on. For one reason, because you have permission as a regular user to view its contents, but also because it's a fairly complex text file with a whole bunch of fields in it. So there's what my password file looks like. The passwords aren't actually stored in here. I think I've talked about this before, but the second field is an X, and the second field is a placeholder for the encrypted file name, which is actually now stored somewhere else on Unix systems. Okay, but if we take one of these lines, like the root line here, you may notice that there's these colons. So in the password file, it is basically a plain text database, just like my shopping list, except for it has more fields and it's using a different delimiter. So the delimiter is colons, and there are 1, 2, 3, 4, 5, 6, 7 fields. The first field is the user's name, and the 7th field is their shell. So let's just see how that works with cut. So if I cut using the delimiter colon, and I grab the 1st and 7th fields from etc. password, what does that look like? So there's the two fields. The first field being that user's name, the second field being that user's shell. So you can go into more complicated files as long as they have a fixed format, the same number of fields on every line and the same delimiting character on every line. Then it's very easy to cut stuff out of every line. So there's a slightly sort of fancier file that you can use cut on. But for the purposes of our lab, let's use our shopping list for just a couple of more. So let's try some piping to sort and just see what happens. So it's cut using a space again and grabbing the 1st and 2nd fields from the shopping file. And now let's pipe it to sort and just see what happens. Okay, so hopefully you can see that in your output if you're doing this, but what it did is it sorted by the item names. So apples, bananas, carrots, Cheerios, eggs, milk, soda squash, tomatoes, and tuna. It's sorted by item name. So by default, it appears that sort is going to sort by the first letters that it encounters. But it turns out that sort will let you target different parts of its input. So let me bring up the man page again and show you this. Somewhere way down here is a -K option. Okay, so this -K option says sort by a key. So this is a little bit confusing, but when we use cut, we refer to the fields. When we use sort, we can refer to the fields by number also, but they're called keys in sort, which is unfortunate that they don't both call them fields or keys. But you can use sort on keys to sort on specified fields. So let's try that. So I'm going to sort on a key, and what I'm going to sort on is the second part, and let's just see what happens. So you have to sort of go back to the cut part and remind yourself what's going to happen. So we're going to cut the first two fields from shopping, which will be the item name and the category of the food. And we're going to sort on the second part, which in theory should be the category of the food. So if you notice now, the first word, they're all scrambled all over the place, but the categories are now sorted: beverage, canned, cereal, dairy, fruit, vegetable. So you can use sort in combination with cut to sort by different fields. So let's say, for example, we wanted to sort, let's grab, instead of the first and second field, let's get the item name and the quantity out of there, and let's see what happens. Now this is going to be not quite right, but we're going to fix it. So it's not quite right unless you think of it alphabetically. So we sorted by the second field, which was the quantity, but what it did is it actually sorted kind of alphabetically by these digits. So 1, 1, 1, 2, 1, 2, 2, 2, 2, 4, 4, 6, which isn't quite right. What we wanted was 1, 1, 1, 2, 2, 4, 6, 12, 12, 24. We wanted these to be sorted numerically. So it turns out that with sort, and you can go look in the man page if you want to, you can specify that you want your sort to be a numeric sort, assuming that the key that you want to sort by is numeric. So now you notice they'll sorted by a quantity, and you can get fancier still. You can say, I want to see those from largest to smallest instead, numerically, by that second field, and you can do that with sort also. Okay, I'm doing okay on time. That's, I think, all of the bits. Hopefully what you're finding when you do the labs, it's very difficult. Like, I don't want to leave you with totally open-ended questions, because people who are brand new to this, to the command line, I feel like giving you something to try in the form of a multiple choice is better than not. So my hope is that you'll actually try the commands and get a sense for what the commands are doing, even when they're not the correct one for answering your question. So that's what I mean to be doing with the lab questions. It's giving you an excuse to try different variations of a command, so that they may not be the command that answers the question, but they may be a command that actually does something that's still interesting to make note of what it did. Okay, a couple of VI things, and then I think we can call it quits. So let me open up my fruits file. So I'm going to sort of just, you can see them off on in the notes there on the right. A couple of things that you can to add to your toolkit. The main things are, can I get into insert mode, can I get back into command mode, and can I move the cursor around? Now I also introduce you to how do you open a new line below the current line, which is the little O, which automatically puts you into insert mode at the same time. We also talked about DD to delete a line, so I'm going to delete this empty line. Have to be in command mode to delete the empty line. That's not what I want. I want this. Okay. So some other things you can do. So hopefully you remember that you can use the X to delete a character. Little U undoes your last change on the current line. That's handy to know. But you have to be careful with that, because if you do an X and then you leave the line, oh no, it still did it. That's good. I guess it goes back to, well, it's not what I had in my mind. Anyway, little U to undo things, DD to delete. Okay, YY. So that YY command, stands for yank, but it's what we think of as copying. So if I do a YY, like on grape, you can't see that anything happened in VI, but what it did is it yanked, or what we would normally say is it copied the line that the cursor's on. So I did a copy of the whole line that grape is on it. Now I'm going to move the cursor down, let's say all the way down to the very, very bottom. If you type P, that's a paste. So whatever you most recently yanked is what you will paste. Paste. So that's awkward because you want to say copy and then paste. Unfortunately, that's just not how it works in VI. It's yank and paste. So YY to yank a line, and then P to paste. The reason why it's two Y's we'll talk about in the not too distant future, because it allows us to do a modifier. But anyway, those I added to the list, YY and P. And then those other couple little things at the bottom. So if you're in a line somewhere and you want to go to the beginning of the line and you're in command mode, you can do the caret. So if you see where my cursor is, if I do the caret, it jumps me right to the beginning of the line. If I do the $ in command mode, it jumps me right to the end. I use the $ more than I do the caret. They both require that you get your fingers on the number part of the keyboard, which not everybody likes. But that's what those are for. No. So I'm trying to save that and work over here as well. Okay, and I mean, I just kind of throw out a bunch of different VI options. For most people, you can get most of the basic work you need to get done with the ability to get into insert mode, the ability to get back into command mode, and the ability to write and quit VI. If you can do those things, then everything else is a bonus. And you may find that you'll really, like, I just happen to remember what little o does. That's useful. But don't stress a whole lot about memorizing VI. Some of you brought up cheat sheets in discussion, and that's a great thing to have at hand, a little cheat sheet on the side that says what's the command to do this. If there is an editing task that exists, there's a command for it in VI. Way more than I will ever memorize in my head, for sure. Okay, so the big G and the two GGs. So if your cursor is somewhere in the middle of the file and you do a big G, so Shift G, that drops you way to the bottom end of the file. So notice the cursor's at the bottom now. So that's the cap G. If you do GG, it jumps you up to the very top of the file. This gets more useful as your files get longer. Now the reason why it's GG is because you can actually target specific lines, but for now we'll just do the GG, the big G to drop to the bottom, GG, little g, to jump to the top. And then Control G actually does a thing as well. If you do Control G, it gives you a little status line at the bottom. So there's sort of three different variants of G. I guess I should put Control G at the bottom. Okay, so the VI stuff I realize is not nearly as, well, I assume it's not as much fun as these other commands. For people who are new to the command line, a lot of this is just about getting comfortable with working in text. Typing a command, pressing enter, looking at the output, and then sort of slowly building up your toolkit of variations and options and redirections you can use to combine two tools into one outcome, that kind of stuff. It's mostly a matter of using it and making excuses for yourself to do some experiments. Because there are man pages, you technically never have to memorize any single command as long as you're aware roughly of what the command is. You can locate the man page about it. So remember that as well. It's mostly about trying to remember, like, what was that command to do a sort? And if you can find the command, then you can bring up the man page, and then you can see how it works, and then try things out. Okay, I need to stop. Thanks for being here if you were here. Sorry if I didn't say hello to you. Several of you have joined since I did my hellos. So anyway, that's my quick walkthrough of this week's content. Just remember, please, the week 9, we're in week 6. Week 9 is the midterm week, and that's the only thing that you do that week is the midterm. It's 50 questions, and they are drawn from the first 8 weeks lab assignments. So please leave yourself time to work on it. There's no timer or time limit on the midterm, but there's no redos on it either. So once you click submit, it's submitted. There's no redos. But you have the whole week. You can start it. You can come back later. As long as you haven't clicked submit, I think you're fine. Anyway, please try to make some time in that week 9 so that you can knock out a really good grade on that midterm. Anyway, that's it for me. I hope you have a great week. Thanks for being here. Thanks for watching later. And I will see you next Tuesday.